Hi, my name is Josh Marvald, and this is my summary presentation for my SLU fellowship, which was analyzing the importance of the serve in professional tennis, and I worked with Dr. Matt Hyam from the statistics department. So our motivation for the project came from Dr. Hyam and I both feeling that there was a lack of valuable player-specific statistics in professional tennis commentary. Um, Both of us had watched professional tennis and felt that a lot of the times commentators would say things that were pretty obvious and apply to all players, like so and so needs to make more first serves if they want to win the match. Stuff like that, which intuitively makes sense but doesn't really add any information uh, for the person watching the tennis match. So we thought that by analyzing the serve with a large data set, we could quantify how a player's probability of winning a match changes with their first serve percentage. And the first serve percentage is just the percent of the time that their first serve goes in. So the data we used was match level data from the past 11 years of Grand Slam matches for men's and women's professional tennis. Grand Slam matches are matches from the four biggest tournaments every year, and match level data just means that um, the statistics generated are over the course of the whole match. So first serve percentage, which was the main predictor we used, was first serve percentage from the entire match. And the data was compiled and made available by Jeff Sackman, who is a sports analyst, but he also provides a lot of data for anyone to use on his GitHub. So this is the model that we decided to use for our project. It's called the Bradley-Terry model, and it's specific to player-opponent matchups. So um, the all the terms with I relate to player I, and all the terms with J relate to player J. And this returns a predicted probability that player I will beat player J given each player's first serve percentage. And it does this by calculating an ability for each player and using the Logit scale to back transform the difference in ability to find a predicted probability. So once we had our model built, we decided to display it in a web app, which we built with the language Shiny and R. So Shiny is a language that's pretty easy to use if someone knows the language R, and Shiny will translate itself into HTML to make it easy to make websites. So our app lets a user select a player of interest and any number of opponents that they're interested in, and it plots predicted match win probability with the predictor first serve percentage. And so here's what the app looks like. These are the two plots it will show. The top plot shows the chosen player of interest against the chosen opponents, and the bottom plot shows the predicted match win probability of the selected player against all opponents. So the user can select a different player of interest and any number of opponents they want, and the app will plot them all on the top one. So for most players, we found they had a positive relationship between first serve percentage and predicted match win probability, but some players had a negative relationship. And while we didn't have enough time to conclusively say why this is, we suspect that this may be due to different players having different serve strategies that have different rates of success. So one theory we have is that players who serve faster and closer to the lines will overall be more successful in their matches, but because they are going for riskier serves, their first serve percentage might be lower, but with the lower first serve percentage, they have a higher success rate, which would explain why they have negative relationships between first serve percentage and predicted match win probability. But we expect to look into this a little further. And these are our sources. All of the data we used came from Jeff Sackman and his GitHub repositories. Thank you for listening.